Okay, hi there, I'm Hao, and this is just another video of me solving random code problem. So we are given a number, an integer in decimal base 10, and we need to count the number of bits of one bit, right? In the binary form. So for example, 11 in binary is gonna be 1011, right? Right. So this one is the most significant bit. So 2 to the 0, 1, 2, 0, 1, 2, 3, right? 2 to the 3, right? Plus 0 multiplied by 2 to the 2, right? Plus 1 multiplied by 2 to the 1, plus 1 multiplied by 2 to the 0, right? This is going to be 8, right? Plus 0 plus 2 plus 1, right? Will give us 11, right? And 1011 have 3 bits, right? So if we take a number and we do the AND with 1, right? It will, the 11 here, the decimal number, right? Gonna turn into the binary form like automatically. So for example, if we take the 11 and we AND with 1, right? So AND mean both number have to be true, right? So it's gonna be like this, right? 1. So like this, right? So 1 and 1, and everything else is gonna be 0. Because to be true, right? Uh, the AND here just like the AND operator in our normal logic, right? So both number has to be 1 in order for the result to be 1, right? So um so we're just gonna count by looking at the rightmost element, the rightmost number, right? Right. By taking the number, the binary in the binary form, right? And we end it with 1, right? So if the least significant bit, the yellow number here, if the least significant bit is 1, the result gonna be 1, right? Right, and we're just gonna add that to our result. We're gonna count, right? So the result is 1, so we add that, and then now we finish counting the least significant bit, right? We just get rid of it by shifting to the right one, right? So if we shift right 1, this gonna become 10101, right? Right, right. The 1 here on the right gonna disappear because we shift to the right, right? Right. So now we just continue to end this with 1, right? If the result is 1, then we add 1 to here, right? And we continue to shift right. So 0010, right? And we keep ending with 1. So this is the least significant bit is 0, right? So the result gonna be 0, right? And we shift right again. So now we have 0001. We end it with 1. We got 1, right? So we add 1 to our results. So we can return 3 at the end. Right. So the base case is when our result is our input is 0, right? So if we shift right one more time, we're gonna get 000. We're gonna have the result gonna be 0, right? So if the result is 0, it is our base case, right? Because if we keep shifting to the right, one bit by one bit, eventually we will reach 0, right? And as we shifting right, we will count the number of one bit by ending it with 1. So we can use recursion to solve this problem. Or we can return, right? If n is equal to 0, then we can return 0, right? This is our base case, because if it is 0, then there's no 0 bit. Sorry, then there's no 1 bit, right? Otherwise, we're gonna count the number of 1 by taking the input and end it with 1, right? If the least significant bit, the bit on the rightmost side is 1, the result gonna be 1. Otherwise, it will be 0, right? And we can add it recursively, right, by shifting the input to the right. But to get rid of the least significant bit or the rightmost bit, that we just count over here, right? Okay, so let's try that, and it worked. Thank you for watching.